Today's topic is logarithms. Okay? Actually, it is exponential logarithms. Logarithm is another way to write the expressions which are in index form, in indices form. If we have y is equal to a to the power of x, the graph of y to a to the power of x is this one, which always passes through 1. Example. Sketch y is equal to 2 to the power of x and y is equal to 2 to the power of x plus 1. For the first one, we can directly sketch it as this one. Okay? Now, for the second one, y is equal to 2 to the power of x plus 1. We have to rewrite as 2 to the power of x times 2 to the power of 1, which is equal to 2 times 2 to the power of x. When x is 0, 2 to the power of 0 is 1. 2 times 1 is 2. So we are going to have such a graph. The same graph, but this time that y-intercept is going to be 2. Now, what is logarithm? If we have y is equal to a to the power of x, let's rewrite in logarithms. This expression here, y is equal to a to the power of x, can be written as logarithm of y to base a. Be careful, this is base. The log and y are on the same line and base a is underneath there, is equal to x. These two expressions are equivalent, such as 2 cube of 2 is 8. Let's write this expression in terms of logarithm as logarithms. Logarithm of 8 to base 2 is equal to 3. If we have an expression in logarithmic form, let's find x. We have to convert the big form to index form. How are we going to do that? The easiest method is that close that log here and move that 4 as the base of 3. So x is going to be 4 cubed, which is 64. That's how we solve logarithmic equation. This is easy, but let's do another one. Logarithm of y to base 2 is equal to 10. And find the value of y. What are we going to do? Write the equation, close that log, and move that 2 as the base of 10. So y is equal to 2 to the power of 10, which is 1024. This is logarithm, okay? This is what we call logarithm. Of course, Logarithm has its own rules. Let's learn that those rules and properties. 1. Logarithm of base A is 0, always. If we have 1 there, it does not depend on the base, it is always 0. 2. Logarithm of A to base A is always 1. If these are equal to each other, it is equal to 1. 3. This is very important. Logarithm of x to base A. If you have a power there n, we can move that power n there as multiplication. This is a very important rule. Let's use it. Find value of logarithm of 8 to base 2. Logarithm of 8 to base 2. Instead of 8, I am going to write it as cube of 2. 8 is equal to cube of 2. As you can see in rule 3, we can move that power there. So 3 times logarithm of 2 to base 2. And if they are equal, the value is what? 1. So the answer is 3. That's the way to use rule number 3. Now, rule number 4. Logarithm of x to base A plus logarithm of y to base A is equal to. If bases are equal and we have addition sign, we can write that one in the form of logarithm of A x times y. Bases are equal, addition. We can write it as a single logarithm here with multiplication. Let's use it. Find value of logarithm of 6 to logarithm of 4 to base 6 plus logarithm of 9 to base 6. Logarithm of 4 to base 6 plus logarithm of 9 to base 6 is equal to. As you see, the bases are equal. And we have an addition sign there. So this is going to be equal to logarithm of 4 times 9 to base 6, which is equal to logarithm of 36 to base 6. Instead of 36, we can rewrite as 6 squared. Take that 2 there. 2 log 6 to base 6, which is 1, is equal to 2. And we have rule number 5, which says logarithm of x to base A subtract logarithm of y to base A. Again, as you see, the bases are equal. We have a negative sign there. So we can write this expression as a single logarithm, such as logarithm of x over y to base A. Let's do an example for that one as well. Logarithm of 5, we have 100 there. logarithm of 4 to base 5. We can rewrite them as a single logarithm in base 5, and we have negative sign there. So we are going to divide 104. That is logarithm of 25 to base 5, which is equal to logarithm of 5 squared to 5, 2 logarithm of 5 to base 5, which is equal to 2. And if the base is 10, if base is 10, instead of logarithm of x to base 10, you can write it as logarithm x. If you don't see any base there, it means the base is 10. For base 10, you don't need to write that base. And we have a final rule which has its own name. Change of base. If you want to write logarithm of b to base a in a different base, say c, this is equal to logarithm of b to base c over logarithm of a to base c. Let's use that one with in a different example. Simplify logarithm of a to base 4. As you know, 8 is cube of 2 and 4 is square of 2. So I am going to change the base from 4 to 2. So logarithm of 8 to base 4 will be equal to logarithm of 8 to base 2 divided by logarithm of 4 to base 2. Now, instead of 8, we can write logarithm of 2 cube of 2 to base 2 over logarithm of 2 squared, which is 4, to base 2. Move 3 as the coefficient, logarithm of 2 to base 2, which is 1, over, move that 2 there, logarithm of 2 to base 2. This is again 1. So the answer is 3 over 2. Yes. Let's use these rules to solve exam type examples. We have I have a reminder there for you. We have a simple way of change of base. If we have x, the unknown, at the base, by change of base rule, we can rewrite that one as 1 over logarithm of x to base a. This is very, very important. Keep in mind that one. Now, exam type examples. Now I am going to use my calculator to help me and solve some questions. Question 1. Solve 2 to the power of x is equal to 7. Correct to 3 significant figures. Now, from now on, if the unknown is at the power, we are going to take logarithms to base 10 for both sides. So if unknown is at the power, this is very important and this is a very strict rule. Take logarithms of both sides to base 10. And again, for base 10, you don't need to write the bases. Now, x is the power, so we can move it there by rule number 3, as you see here. We can move the power there. So, x logarithm 2 to base 10 is equal to logarithm 7. We are going to apply a division here. X is equal to logarithm of 7 divided by logarithm of 2 to base 10. I am going to use my calculator for that. We have a logarithm sign there to base 10. Log 7 divided by log 2. And the answer is 2.807, and correct to three significant figures. This is going to be 2.81. Now let's solve another example. Exam type example. So solve 3 to the power of 2x minus 7 times 3 to the power of x plus 12 is equal to 0. Now, 3 to the power of 2x minus 7 times 3 to the power of x plus 12. I can write 3 to the power of 2x as 3 to the power of x squared. That one is equal to that one. Minus 7 times 3 to the power of x plus 12 is equal to 0. Now I am going to use substitution here. Y is equal to 3 to the power of x. So y squared minus 7y plus 12 is equal to 0. Y minus 3 times y minus 4 is equal. Y is equal to 3, y is equal to 4. So I am going to substitute y with 3 to the power of x is equal to 3. Here x is very simple, 3 to the power of 3. And here we have 3 to the power of x is equal to 4. Here the unknown is at the power. So what are we going to do? We are going to take logarithms to base 10 of both sides. So log 3 to the power of x is equal to log 4. Take this x there as the coefficient. X times log 3 is equal to log 4. X is equal to log 4 over log 3. Use the calculator. We have a fraction there. So log 4, close the bracket, write log 3, close the bracket, and get the answer, which is 1.26, correct to three significant figures. This is another exam type example. And the page number was 5. Now Case 6. Now, in example 3, example, I am going to use change of base. Logarithm of x to base 3 minus 7 times logarithm of 3 to base x is equal to I'm going to make this one 10 and that one 7 to have a proper example. Yes, solve for x. Now, logarithm of x to base 3 plus 10 times logarithm of 3 to base x is equal to 7. As you see here, we have the unknown at the base. And by change of base rule, I can derive that one in the form of 10 times 1 over logarithm of 3, logarithm of x to base 3. Remember change of base, the simplified form of change of base is equal to 7. Logarithm of x to base 3 plus 10 times 1, 10 over logarithm of x to base 3 is equal to 7. Here I'm going to use another substitution and say that y is equal to logarithm of x to base 3. Y plus 10 over y is equal to 7. Multiply the whole expression by y squared plus 10 is equal to 7y. Y squared minus 7y plus 10 is equal to 0. Y minus 2, y minus 5 is equal to 0. Y is equal to 2, y is equal to 5. And use y is equal to logarithm of x to base 3. Logarithm of x to base 3 is equal to 2. So close that block. Put 3 as the base of 2. X is equal to 3 squared. X is equal to 9. And do the same thing for 5. Logarithm of x to base 3 is equal to 5. So close that block. X is equal to 3 to the power of 5. And x is equal to 243. 3 to the power of 5 is 243. And today I am going to solve 4 exam times examples. So this is going to be the last one. The question is logarithm of 2x plus 1 to base 3 is equal to 2 times logarithm of 7x minus 1 to base 3 minus 1. We have to solve this one. So what are we going to do? I am going to write, take that 2 and make it the power. Apply rule number 3 in the opposite direction. So this is 2, sorry. Now, I am going to move that 4 to the left-hand side and take that logarithmic expression to the right-hand side. So 4 is equal to logarithm of 7x minus 1 squared to base 3 minus, it was plus, on the other side it is going to be negative, logarithm of 2x plus 1 to base 3. As you see, here we have equal bases 3 and we have a negative sign. So what are we going to do? We are going to divide them and have a single logarithmic expression. So 4 is equal to logarithm of 7x minus 1 squared over 2x plus 1 and the base is 3. When you have a single logarithm, close that log and move that 3 as the base of 4. So 3 to the power of 4 is equal to 7x minus 1 squared over 2x plus 1. This is 81. 3 to the power of 4 is 81. What is the square of 7x minus 1? It is 49x squared minus 14x plus 1. And we have 2x plus 1. Now I am going to move that 2x plus 1 there. So 162x plus 81 is equal to 49x squared minus 14x plus 1. So 49x squared minus 176x minus 80 is equal to 0. We have to solve that one, and it is not going to be easy to solve that one. Let's use our calculator to solve that one. Actually, can we solve it? Let's check. Now, A is 49, B is 76, C is minus 80, I am going to apply the formula. And let's get the answers. X is equal to what? In a minute, I'm going to give you the answer. One of the answers is minus 20 over 49. And the other answer is I'm going to change the sign here. The other answer is 4. Yes, this is the end of the lesson. Then these are the exam type questions. I'm going to send some exercises for you, okay, from our group. Do you have any questions?
Benim yok hocam, teşekkür ederim.
Okay. And on Friday at 10 o'clock we are going to have another lesson, okay? And you can find this video in YouTube.
Tamam
Okay?
hocam.
See you.
Görüşürüz hocam.
Görüşürüz.